Hi guys, it's Mrs. Warner. I'm so excited for our first trig lesson, and our lesson today is on trig ratios. Most of this trig chapter should be reviewed from the beginning of this year and from your previous year in geometry. So first of all, trig is super important. It works with right triangles, and it helps us to find missing sides and missing angles in right triangles. Hopefully you can see our notes on the screen. And the main important thing is you have to know where you're standing when you're using trig. You have to know where your reference angle, it is called. In this picture, the reference angle is noted with the Greek letter theta. Theta is the symbol that is often used to refer to the reference angle. So if we're standing at the reference angle here at A, then to theta, side BC is our opposite side. This would be our adjacent side to our reference angle. And of course, across from the 90-degree angle is always our friend, the hypotenuse. Now, the reference angle can change. It has to be one of the two acute angles of the right triangle, or the angles less than 90 degrees. So now if our reference angle is up here at B, I'm not sure what's going on. If it's up here at B, then the opposite side is over here to our theta, and our adjacent side is here, and our hypotenuse still stays across from the right angle. Our three trig functions that we use the most are sine, cosine, and tangent. So the sine ratio in a right triangle is equal to the opposite over the hypotenuse. So in our picture of theta, it's equal to the opposite leg over the hypotenuse of the right triangle. The cosine is equal to the adjacent leg over the hypotenuse. So A over H. And the tangent of theta is equal to the opposite over the adjacent. So tangent equals opposite over adjacent. So basically, if you know our little acronym SOHCAHTOA, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. If you know that acronym, you can solve pretty much any type of right triangle trig problem. So it says, using the right triangle below, state the value of the three trig ratios. So if I wanted to know what the sine of theta was, I'm first going to look at my picture and find theta. I'm going to label my hypotenuse. So across from the right angle is my hypotenuse. Across from theta is the opposite, and this would be my adjacent leg. Now sine is opposite over hypotenuse. So in my picture, it's the 3 over 5. The cosine of theta is going to equal the adjacent over hypotenuse. So in this picture, it's 4 over 5. And then our tangent of theta is going to equal opposite over adjacent. So it's 3 over 4. So those are our three trig ratios for this particular triangle. That's right. Let's try a different problem. Our sides are now 7, 24, and our hypotenuse is 25. We're going to move from angle A and angle B. If I'm at angle A, my sine, if I use SOHCAHTOA again, SOHCAHTOA, oh my God, that's driving me nuts. The sine from A, my opposite side is 24. So this would be 24 over 25. The cosine of A would be my adjacent side, which is 7 over 25. And my tangent is O over A, that's 24 over 7. Tangent can be a fraction that's bigger than 1. Now, if I go down to B and I do the sine of B, my opposite now is 7, and my hypotenuse is 25 still. So notice that the sine of B is equal to the cosine of A. So in other words, the cosine of B is going to equal the sine of A, so that's 24 over 25. And then your tangent is O over A, and in this case, it's now 7 over 24. They've just reversed or been the reciprocal of what the tangent of A is. There's some fun stuff that happens in there. In our next problem, we first need to solve for x and then state the value of the three trig ratios. Oh, well, it's a right triangle. Our favorite thing with right triangles is a squared plus b squared equals c squared. So if I do my two legs, which go in for a and b, 5 squared plus 12 squared, they can equal my hypotenuse, which is x in this case. So 25 plus 144 is equal to x squared, or x squared is equal to 169. And in order to solve that, I'm going to take the square root, so x is 13. That means my hypotenuse is 13. Now if I use my SOHCAHTOA again, my sine of theta is going to equal the opposite, which is 5 over 13. My cosine of theta in the picture is going to equal my adjacent, which is now 12 over 13. And my tangent of theta is going to equal my opposite over my adjacent, so 5 over 12. And I don't know how to get that annoying message off, but I'll figure it out. And there's your video on your first trig lesson from home. That would be your trig notes day 1. Hope you have a great day, and I hope I get better at doing this. Bye.